K-nearest neighbor is the first supervised classification method we will look at. This algorithm is simple. In this example, we have three classes: orange, green, and red. This algorithm requires a parameter k, which represents how many data points we will be looking at in order to classify a new point. For this example, we will choose k to be 5. In any supervised learning algorithm, you need a training data set. The class of each data point needs to be known. When we want to classify a new data point, we find the k nearest neighbors of this point using a distance measure. For example, the Cartesian distance. In this example, we can see the 5 nearest neighbors of our new point as k is equal to 5. The majority class of the neighbors define the class of the new point. In this case, we have 4 orange neighbors, 1 green, and 0 red. Therefore, our new point is classified as orange. For this algorithm to work, you need to have sufficient training data where the distance of a new point and its k neighbors have similar distances. If 3 neighbors are close and the 2 other neighbors are far away, the result will not usually be successful. Another important thing is to have equal data points in the training set for each class. Otherwise, the model will be biased towards a specific class that has the most data points. Now let's look at how to use k-nearest neighbor with scikit-learn. The first thing we will do is generate 3 types of data sets that we will be using nearest neighbor on. The first data set we will use make moons, the second one make circles, and the third one we will have a linearly separable data that we've generated here. After we've generated our data sets, for every supervised classification algorithm we will look at, we will need to split our data into training and testing set. So we do the splitting using train_test_split function from scikit-learn. We pass x, which is the data set that we have, and y, which is the classes of each point in the data. And then we specify the size of our test, which is in this case is 0.4. This is a ratio out of 1. So that means that 40% of the data will be test data. We can also pass the random state for the splitting. The rest of this is just to plot the data with 2 colors for the 2 classes we have, and to use a lighter color for the testing points that we have. We can look at our 3 data sets. You can see that the first one and the second cannot be separated linearly. Like we can't just draw a line here and have a nice separation between the 2 classes. As for the third one, this is our linearly separated data set. Now, because of some noise, it is not perfectly separated, but we can notice that one is on the right and the other is on the left. We will use k equal to 3 with k-nearest neighbor to classify these data sets. We've already imported k-neighbors classifier from scikit-learn library, and we will pass value 3 for the k parameter. We will store our classifier in this variable CLF, which stands for classifier. And in this for loop, we are going through our data sets one by one. For every data set, we are storing the x and y, which is the points that belong to this data set, and y is the classes for each point. We will first standardize the data, especially because, as we've mentioned before, in k-nearest neighbor, we are basing our comparison based on distance. And if we don't standardize the data, the distance can be biased towards a specific range of the data or specific class of the data. After we standardize our data, we can split our data set by 60% training and 40% testing. And we will get 4 different arrays. The first one is the data points for the train, then the data points for testing, then the classes for the train, and the classes for the testing. we can fit our model on the training set using the function fit. This is CLF is our classifier. We call fit and we pass the training set with their classes. Remember, in supervised learning, we need to pass the classes to the model to learn from it. We will generate the accuracy score by calling score function, and we will pass our testing data. What this function will do, for every point in our testing data, it will predict the class that this data belongs to based on what we've trained before, and it will predict a class. Then it will be compared to the actual true class of this data point, and the score is basically a percentage of accuracy. The rest of the script plots the result in a way that it colors the mesh of the plot based on in which class the model predicted it is. So if we look at the result, we can see how for every data set the regions got classified. Because we are looking at the nearest neighbor, so we can see that in the neighbors where we have more than 2 classes, the regions got lighter here. It is not 100% blue and it's not 100% red. This is a very simple algorithm, and in some cases it can be used very well. However, it can also be not efficient, because for every single prediction we're going to do, we have to calculate the distances of this new point with everything in this data set to find the k nearest neighbors. However, in such data set, we got a 0.97 accuracy rate, and in this one we got 0.93, and the third one we also got 0.93. So this is good results, but however, our data set is quite simple. K-nearest neighbor wouldn't be able to learn more complex classification like other models that we will look at